In my last video about my Minecraft clone, I showed that I added entities, and I also said that I created a compile time entity component system for it. This video is a full live record from my Discord server, where I explained how it works. For most of the video, I talk about templates in general, but don't worry, it's on purpose. The code for the entity component system itself is not that big, so I talk a lot about templates things, because once you get familiar to all of these concepts, the entire system will quickly make sense at the end of the video. So if you're interested in how I architecture things, stay around, even if you already know templates, because I also show some quirks of templates, so you might learn something new. And finally, on my Discord server, I have some special channels with nice online resources, including template stuff. But now, let's get into the live call. Yeah, that's also important. Yo, let's go, crocodile. Yo. Okay. So can you share the screen?
Me?
Everyone.
Why?
At least one person. Can at least one person see the screen?
Yes.
Okay,
indeed,
this is
yes.
good enough. Okay. So, let's first do a recap on templates because
My hand. What the hell are templates?
yeah, exactly. That's why we are doing a recap on templates. So
okay.
the idea is this. Let's make a function void add. Well, it will be an int add, int a, int b, and we want to return a plus b. Okay, everything is good here. So
I think he cuts us our voices.
see
I'm
out.
saying this true.
Okay, everything good so far. So what's the idea? The idea with templates is to reuse the same function, but using different types. So we'll start with some stupid examples, but it will make sense later. So for example, let's say I want to make an add using some float. I can make it by hand if I want to look like this. And now we have overloaded this add, which I think everyone knows what this does. So basically I have two adds right now. One uses floats, one uses ints, and I can, for example, do this here. So this will call the second add because it's using floats, and this will call the first add. Now, if I do this thing here, I get a compile error. Now, question for you on stream. Why do you get this error here?
I don't know,
Because you
because
can
one
either
is float,
pass
one
in
is
a float and a float, or int and an int. You cannot pass
Because
a
it's
false
a-
and an int.
Yes.
Because it's
It's
a
maybe
function.
it's because it's the first function, even if it's float, you know.
It says that if you look at more than one, it says overloads matches.
Yeah.
So this is an ambiguity problem, like it doesn't know which one to pick. Okay.
Yeah.
So it's important, and there are many like pitfalls like this. So for example, if we say void foo here, let's say int a, this is good, and then we say I don't know, let's say a pointer. Okay. If we say foo of 10, this will be good, but if we say foo of 0, this is also good. This is also good, but what if we say...
Because it probably thinks that 0 is for ints.
Yeah, 0 is for int, but check this out right now. What if we say this?
Yeah, because it's like...
So it has either to convert to a float or to a pointer, and both can convert from 0 to something. Like if I put 1 here, it's gonna convert to a float. But 0 can also convert to a null pointer, yeah. But anyway, let's go into templates right now. So the idea with templates is instead of rewriting this thing multiple times, you can write template here with this weird syntax. And this T is a type, because I said here type name. So what this means...
any name, right?
Yeah, it can be a type, like int, float, anything. Okay?
Like the name of it can be anything. It's not specifically T, because I usually see people using T, and I'm like,
yeah, you can say whatever you want, but
okay.
You know, people use T, U, and stuff like that. Okay, so this means that I can put this type here. Now, the compiler, when I'll use this function, I can say, for example, add of type int, and then I can call, the arguments here. This int here will be replaced literally, like the compiler, whenever the compiler will see this, it will say, okay, we have a template here. It will literally create a new function to use it here. It will literally do this under the hood. It will create this overload inside its memory to call it here. So this means, for example, that wait, first of all, I think you understood the concept so far, right?
Yeah.
Yeah. Okay.
Yeah.
So first of all, this means that if I do something like, I don't know, let's say float, let's say double, let's say short, let's say unsigned long int or something, and also let's say long double, because that thing exists. This thing will generate the function for every overload. And this actually means that if this function is very big, it will actually take a lot of space in the computer's memory. And well, to be fair, nowadays it's not a problem. Like we have enough memory in the computer, but it just
It's better
shows.
to use less memory.
Yeah, of course, but there's actually another problem, but we'll get to that later. But it just gets to show you how it works. It just creates another copy of this function, literally, just another copy. And what is a problem, however, is the compile times. That can get if you use a lot of templates, the compile time can actually take quite a lot longer. But not if you use like simple things like this, like if you use a lot of templates. Anyway, so this is the basic idea. Now, if the template can deduce the arguments in modern C++. Now, I don't remember exactly what versions, but I think in the first version, like C++ 11, it didn't deduce it automatically or something. Now in C++ 17, it deduces it quite well. And there are complicated rules and stuff. We don't get into that. But if I do something like this, this one compile actually. Wait, it compiled because it used this one, I think. Yeah. So this one compile because it won't know. It's the same thing. It's either a float or an int, But if I say here int, it will force it to use that type, okay? But if not, it will just deduce it from its context. It will see, hey, this argument is a float. Let's put a float here.
Yeah, but
Yeah,
what
like
if
a
you
dynamic function. Every time you call it, it's gonna copy, and you can specify which type of.
Yeah, you can specify it's optional. Okay.
Oh, nice.
Yeah, but what if
Yeah.
so you specify that the template is type of int, and one of the values is float, another one isn't going to return an error trying to convert a float to an int?
1 second, I'm also checking if I'm recording. Okay, I'm recording. Okay, let's go back. Again, can you repeat?
Okay, so in the add function, you specify that it's supposed to be an int, but one of the values is int and the other one is float. It's going to return an error because one of the values is passed by a float because it doesn't seem to show it as an error.
I think it just cuts off the floating point. And
Right, like this?
Yeah, and just add int after add, like just specify that it's an int.
Yes, it's who is talking about when you said that you can convert floats to an int. I don't know if that will give you an error. So if you have float and you specify that it's an int,
Like if I
will it
said,
convert?
if I had another.
After the add in the
Yeah,
function.
you specify that it's
Yeah,
an
when you
int.
declare the.
Like this?
Yeah. No,
Yeah,
int.
Or float.
Or int, yeah, whatever.
Yeah.
This compiles because it. So the problem here is that it's ambiguous. Like the template doesn't know what to pick. Like I'm telling it, okay, this is supposed to be an int, and then I'm telling it this is supposed to be a float. So there's no such rule. Let's pick the first one. You know what I mean? Like they have all to be the same. Like it won't just pick the first one. But instead, if I force it to be a type, it will just pick that type for everyone and cast everything
so if it's not of that type, it's gonna try its best to convert to it.
Yeah, it will do casting, so it will convert these floats to int.
Floor or round it.
Yeah,
Just
exactly.
gonna cut the floating
It
point.
will cut, yeah. Okay. So this is the basics of templates, and you can use them in also in structs and stuff like that, and also in we'll see here in variables, which is kind of cute. I think this is C++17, not sure. I'm not using these features very often, but
I
anyway.
don't know. It seems useful now that you reminded me of it. I remember that I quite often use this in C#.
Yeah, well, I suppose they're a little bit different there, but the idea is probably the same.
But I
C-sharp.
mean, you
It's
need to be
C-sharp
very
Java.
careful with them.
What?
Yeah, you need
I
to be
mean,
very careful.
yeah, yeah.
Well, actually, another question about templates. I don't know if you're gonna cover this or no. Can you specify which types the template can be?
Yeah.
For example, like saying that the template can only be the types of int, float, uint, and stuff like that.
Yes, you can. I won't go into details. By the way, after this talk, if you want to learn some more, I think I have here. Let's see. Let me see if I have the video. There's a very good. Yeah, these two videos, especially this one, actually shows advanced template stuff. I can show you some things, but I won't go into much detail here. But yes, you can do that, and I'll actually show what's the idea behind that. Anyway,
Or as an example, you can think about vector. When you write vector,
yeah,
it's
the
like
vector
a
is a
template.
template. We can actually take a
And
look at
when you
that.
specify the type, it's just the same like you would specify T.
Yeah, well, it's a template. One important thing about templates, if we look inside the vector here, you can see that it's this is the header file. Like its entire code is inside the header file. It's not in a CPP file. And the important thing with templates is that they are computed by the compiler. So the compiler, when it is this vector here, it will, as I said before, it will create all of the code to create the vector with int. But in order to do that, it needs to see the code for that vector. So basically, whenever you have templates, they need to be inside header files. So you probably know how header files work. They just replace the code here inside the CPP. Like literally, if I go inside this header file, including this header file just literally means copy pasting the code from the header file inside my CPP file, right? And the compiler needs that the compiler needs that code in order to do the template stuff. So you can't put, like, you can't declare the define the function in a header file and declare it in the CPP file like you do normally if it is a template. Okay.
Yeah.
So yes, if we start looking at the vector, it is actually a template, but it's kind of very hard to read and horrible. And that's kind of the problem with C++. Like, they have these nice features, but if you want to write your containers yourself, they are kind of horrible to write. And all of these things that you see here, like, they are needed to be done in order for it to be like perfect, like not have edge cases and work perfectly with all of the C++ versions and stuff. And like, yeah, that's just horrible for a normal person to write. So I would say don't go too far when using templates. By the way, GLM, the mesh library for OpenGL, is also heavily using templates. Like, the vector is really just a generic type vector of size 2 and of type float, for example. This is a vector, you know what I mean? And by the way, let me show you another thing. Test a, let's say, int. Templates can actually also take, besides types, they can also take ints or stuff like that. So for example, we can say it int n, can say return a plus n here. So, well, this is a stupid example, but
isn't this highly useless?
yes, here it's useless, but it has uses, and you'll see immediately. So this basically prints 12. Now,
for example, like if you want to have a compiled time array, this is useful. It's a very
yeah,
good feature.
exactly. Compile time array is an example, and here this is like a compile time array actually. Like, this is an array of 2 floats. This is an array of 3 floats, and this is an array of 4 floats. And you have to be very careful. This thing, this 2 here is done at compile time. So this means if I do something like, I don't know, int a equals 2, I can't do this here. Okay? Like this has to be known by the compiler. Now, of course, if this was const, like I guarantee to the compiler that a will remain 2, it can deduce it here, but if it's a normal variable, I can't use it here, okay? It has to be known by the compiler and done at compile time, because the compiler, again, needs to generate a different function for every template instance. So like if I say this thing here, then I start filling numbers here, this thing will be, the code for this test function will be generated like 10 times in the source code. One for each, instance of n. Okay? So, does it make sense so far?
Yeah.
Yes.
Okay. Other,
When you specify the a,
Okay.
it's like in the arrays when the number needs to be constant.
yeah,
Right?
yeah. The array also needs
It's
to be
basically the
constant.
same thing.
Yeah, exactly.
Can you show after this a way to implement templates in C, please? Because some people here use C.
They don't have templates in C, so
I mean, you can implement them still. I implemented dynamic arrays. How can templates be?
well, this is something made by the compiler. You have to implement the compiler.
Oh,
Like this is, again, you're working with the compiler here. Okay. We have a lot of stuff to cover. So next, another important stuff about templates is that they are evaluated when you actually use them. So for example, if I say something like this, let's actually try to compile this. This should, okay, so why didn't this fail? Like this makes no sense here, okay? If I compile this,
not called.
yeah, exactly, it was
So
not,
it was not created.
yeah, so this thing, like the compiler is not even reading it, okay? Even though it doesn't make any sense, it will just ignore it. I suppose if I start, if I start adding like parentheses and stuff, it will break, but you get the idea. It's not evaluated at all until you do something. And also, let's say I make another template and I say increment health. And this will be, I don't know, entity. Here I can say entity.health plus plus.
sorry, but what does that mean? I never saw that syntax in my entire life.
What?
Like the T space, I mean, like the borrow, I mean, and entity. What is that? Is that like a pointer?
It's a reference. It's like a pointer. Okay. So this will actually start making sense because this starts to be similar to what I'm doing in my Minecraft clone actually. So things will start to get interesting. So let's say I have the struct, I don't know, zombie here. Int
You have
health.
property,
What?
health, damage, whatever. I mean,
Yeah.
you have property. You make a reference to that certain property, which is health.
Yes. Let's
Then
create
you
a
assign
zombie.
a type, which type you want, if you want, actually.
Okay, so this will increment the health of the zombie. But the template doesn't care what's the type of the entity when you write it like this, right? It just needs to have a health member, okay? Which it does. So for example, I can make a struct player and he can have some different stuff. Okay. And I can call this function
variable.
greatest variable in existence, I know. And
yeah, don't forget the space there.
yeah, very important. You can actually put spaces in Zig, I think. Do you? Maybe. Yeah, you
That
can.
sounds like an awful idea. Why?
It is. No, it's
Yeah.
like something like, I don't remember. They have a special syntax for, I don't, okay, anyway.
Okay, yeah.
They have a special syntax to do that. But anyway, the idea is that you can call this thing here with both the zombie and the player, even though they are totally different structs and they don't inherit from something common, you know. So this is the important stuff. Like, it just needs to have the health variable, and it can even be of another type. Like, it will just be replaced by the compiler. It doesn't care what it is. It just needs to be there and compile, like, you know, be able to increment it like this. That's
Oh,
all the
nice.
requirements. So this is actually like how I made the entity component system compile time in the Minecraft clone. So we'll look at that shortly. I'm almost done with the template stuff. Just a few more things to show here. So I could also have set the struct, I don't know, health component. I could move the health here and then just inherit from it like this, and it will just add the health component, or I could just write it myself here. Like, it doesn't matter where the it doesn't matter where the struct got this member. It just needs to have it in order for this function to work. Does it make sense?
Yeah.
Okay. So where do we get from here?
Okay, but
Yeah.
what if, for example, oh, okay, nothing.
Okay, in general, next thing. In general, I would do something like this. I would make this as a member. Well, it doesn't make sense here because this has only one member, but usually components would have multiple members, right? So usually I would do composition and stack members like this. And I also recommend you to do this thing instead of using inheritance, and I'll show why. But in my case, I use inheritance from my Minecraft clone because it allows me to have this syntax here like this. So my things, my entities, just need to have the members that I'm using in the common update functions, which are
Oh,
templated.
because otherwise you would have needed to use entity.health.health plus
Yeah.
right? Okay.
.health, and for other entities it will have been this. Sorry. So I would
But
have
if you use inheritance and you just declare the variables in entity,
well, that's the thing. I want to have both
you can
options.
just use them. Oh,
What?
okay.
I want to have both
Me- me-
options, and you'll see why later. What?
Yeah. Okay.
Well, actually, I explain now why I need both, because I might look. So, for example, I have a component which is called. We can look at that right now. Body. It's called body orientation. Okay. So this is like where the body is rotated in the world, and also it has the head orientation. Okay. So this is where it's looking. But I might have entities like shulkers, let's say, that don't have a head orientation. You know. So I just need one component from this thing. So that's why I wanted to have flexibility. I wanted to be able to, you know, inherit from some pre-made components, or just add one member, only one member that I need, and reuse it later. So that's why I wanted to have both inheritance or, you know, just adding members myself. Public health. Okay, so does it make sense so far?
Yeah.
Okay. The next cool thing. So instead of writing this here, I can use a lambda, which looks something like this. Has anybody seen a lambda before?
Yeah.
Okay, so
Yeah.
for anyone watching the recording who hasn't seen one, this is just a function. The difference is that it's not global. Like, it's close to this function here, and you can also reuse stuff outside it. Like, for example, here I can use the z and p variables here, which I actually don't want. So I'll, like, this thing here tells the lambda that I can use these things here, which I don't actually want. So I'll remove it. Now, lambdas also have templates, but they have a nicer syntax. So instead of writing this template here stuff, you just say auto here, and
I have a question.
yeah,
It will automatically
yeah,
deduct
it will
what you
automatically deduce that. Sorry. Okay. You
After
can see
I
the question.
after I asked like about implementing into C, there was a small talk and someone suggested using void pointers. Could that actually be a valid use to use void pointers instead of templates because they accept any type? I mean, in C++, that would be just the auto
Well,
variable.
the difference is that the template gives the compiler some compile time information. So like, wait, 1 second, sorry for this. So the difference is that if I say here increment health here, okay, the compiler will know at compile time, like this increment health is called on a zombie, and then it will know that it's called on a player. And so it will be able to optimize stuff better for this, you know? Does that make sense? Well, I suppose using void pointers, you can also do some optimization if you cast them back.
The thing is with the void pointer is just pointing to a certain variable, you know, and it's like, yes, you say it's auto because it's void, and then when you're pointing to a int, it will realize it's an int. But
Yeah,
it's
if
kinda
you cast it, okay, fair enough. But yes, in C you can use void pointers instead of templates. But you'll see that templates have some other very useful quirks, which I'll show here once we get to the Minecraft code.
They quirky.
What?
They quirky.
Okay, so getting back to here. So lambdas are just functions, and they also have some. They also have template arguments, okay, but they just use a nicer syntax. So I can just say e dot health plus plus, and then I could just say this. Okay. Everything okay so far?
Yeah.
Okay. Before we get into the last thing about templates, I want to,
By the way, oh, okay.
yeah, ask.
What is the difference between? It's probably a big difference. Like, it's just not coming to me right now. What is the difference between lambdas and macros? Aren't they like the same thing?
No, lambdas are functions. Macros are also at compile time. And also macros are like more than at compile time. Macros are actually work on the text editor level. Like if I
What does
say
that mean?
define, I don't know, pi, which is 15926, I don't know, I don't remember. Okay. If I say cout pi, this will literally take this thing here, it will copy it
Oh, okay, I
and
get
will
it.
place it. And to show it, I can just say define what the fuck and put this thing here and say here, and this will compile perfectly. You see what I mean?
Yeah.
So macros are just operate on
Compile level.
not even compile level, file level, like text level, and you kind of like they are useful. You can do some meta programming stuff with them, which are kind of cool.
They are the only way to do something cool in C. Let me tell you that.
Yeah, yeah, they are the only way to do something like this in C. Okay, so one more thing about inheritance and yeah, why I said to not use inheritance in general. I like using components, and then so let's say I want to have a struct, I don't know, rigid body position whatever, and then this will have a rigid. So this is what I would do in general, like not in this case here, which is work well with inheritance. And what's the idea is that you can have multiple things like this. Let's say you have a rigid body and I don't know, like something like animation stuff, which could have like bones. Okay. And then you would also have an animator, and the animator's role is like to load the animations from the from a file and stuff. Now, usually people, what they would do is that they would use the inheritance and the polymorphism, but the problem with those is that they are very linear. So like A can inherit from B, which also inherits from C and stuff like that, but they are very linear. You see what I mean? Like they can go in only one direction. What I like to do is, instead of using methods and polymorphism, I like using functions instead of methods. So if I want to animate something, I could just say void animate. Like usually people would just put this method inside the animator, let's say, or I don't know, maybe they would create a second class which has both of these classes, but I would rather just have it separate as a function which takes a parameter which takes animator as a parameter, and also the let's say animation, and also a rigid body. What's the advantage here is that I don't need a special class that inherits from a specific thing to animate my stuff. For example, let's say in the future, when I write my code, I realize that I need some entities in my game that don't have a rigid body. Why? Because, for example, they are tiles entities. Like in Minecraft, chess, for example, is an entity, but it's also a block. So it doesn't have a rigid body because its position is actually determines in a separate way. It's it's there in the world, in the cubes mesh stuff. You know what I mean. So then, if I were to use polymorphism and inheritance, I couldn't call this animate stuff on my chest because the
Yeah, it
chest
makes
doesn't
sense
have a
because
rigid
it would
body.
yeah, it would inherit everything, and it's pointless.
But right now, if I would have like a chest which has this component, has the animation, the animator will just come from outside, and I can create a rigid body in place and put its right parameters in order for it to work. Did this make sense?
Yeah,
This
kind
does
of.
make sense, although I have one question, which is about your Minecraft clone. Uh, are you planning on doing an ECS talk like this about how you use it in Minecraft? Because I'd love to join.
Yeah, this is actually what we're gonna talk about next.
Oh my god.
Yeah,
How
Yeah.
much
I
time approximately is it gonna take? Because it's pretty late for me.
so everybody's
Uh,
curious about ECS and
just half an hour more, I think.
Half an oh, I can stay like this.
Okay. It's actually not
Go
that
for water.
once we finish this like template stuff, it will be very fast. But we had to do this template stuff before. Okay, so last template related things that I'll show, and then we can actually look at the ECS stuff. So this magical thing here that actually ChatGPT helped me write it. Yeah, so template stuff are horrible. ChatGPT knows how to write them, so you can use it very nicely. So this magical thing here actually can tell me if something has a specific member or not. So let's take a look at the example. This is an example. So this is a client entity. We'll see what is this later. And T is the type of the entity, like zombie, pig, okay, dropped item, player, you get the idea. This magical thing here will tell us if this entity has the body orientation component. Now, before we look into how this works, let's take a look at what this const expire if is here. So, if we go back here, if I say if 0, no, okay, this thing will always return yes, right? Well, modern compilers are smart enough so that they can see that this is constant. So they can just throw this code away. Like, it doesn't have to be there. Well, if you switch on release mode, that is, if you optimize. Did this make sense so far?
yeah.
Okay. But you can't, let's say I have a variable, a, that doesn't exist. I can't increment this here because it's a compile error. even though this thing will never run, I can't compile it because A doesn't exist. What const expire if
And
does,
that's
for
why
example.
you should use Rust and not C++. Okay, continue on.
No, I'll kick you from the server. So
It just does what's the name?
Wait.
Constant expression is like.
wait, like Rust would allow you to do this?
I don't think it will.
No.
I can check it right. I'm gonna
No,
check it right now.
It shouldn't. Anyway, if you do const expire if, however, and let's see, int let's try this. I never tried it. Okay, this actually didn't work, but I can show another example that will work. Let's create a lambda. So L equals some stuff here, okay? Return 0, okay? Good. Now, if I say an if here, return 0, else return 1. If I say 1 plus 0 here, this will fail to compile. Why? A lambda needs to return only one type in order for it to deduce at compile time what this function will return. Like if I say here cout L, and also call it, and remove this thing here, it will say that, look, you can see that it says that it returns an int, right? And he knows that because I return an int here.
Update Rust does not allow you to do that.
Which is expected. Okay, so I'm returning an int here, so this will return an int. If I do this, well, it can't figure out what to return, either a double or an int. But if you do const expert here, can't type today, this will work because
What does const expression mean?
it means something that it's evaluated at compile time, basically. It's like it means something that is known at compile time. So getting back, this will work because an if that is evaluated at compile time allows you to do stuff like this, to basically change how this thing works. So I can literally change the return type of this thing here based on a compile time expression. So if I change this to a 1, this will suddenly, this will be an int, and if I change it to a 0, sorry, this will be a double. You see? If I change it, it changes its type using an if. Which is kind of cool. And it allows us to do stuff like this. So this class here, if it has this member, I will just return it. And if it doesn't have this member, I'll return a default value. And you can do something like this with a normal if. Because with a normal if, you are returning something that may not exist at all. So it will give you a compile error. But with const expert if, I can do stuff like this. Did this make sense?
It's similar to switch.
Well,
Kind
yes,
of.
but in this switch you can switch stuff at compile time. You are literally
Yeah,
manipulating,
yeah.
yes, how this thing works. Okay. Let's also take a look at how this works very quickly. So, this is a boolean value, const expert boolean value, that is templated, and it can have two values, true or false. Now, this is called a specialization of the template, which means that, so for example, if I do template class T here, void foo TA, this is a template stuff. I can also do a specialization for it, int. So this is, I don't know, let's say it's a reference. This is the default templates thing. This will just increment things by 1. But if my template is an integer, I can do something different. I can increment by 2. This is called the specialization of the template. So if I call foo with floats, with bools, with anything else, it will increment them by 1. But if I call this foo with an int, it will use this thing here. Does it make sense so far?
Okay,
Yeah,
but okay.
it's kind
Let's
of
say
nice.
you specify the function, right? I mean, you write the function, you specify that it's gonna do an end. Is it gonna do the first one or the second one?
If I specify an int, it will do the second one.
Okay,
Like if
but
I
what if
say
you don't specify anything and pass in an integer value? Is it gonna do the second
the
one?
second one,
Oh, okay.
it will just what is it? What doesn't it like? Oh, it has to be a reference. Okay, it will use this one because it will deduce that t is an integer, so it will go here. Now, going back to here, there are some rules to the templates. One of them says that if a template doesn't work, just discard the specialization. So in this case, this thing here is just a stub that does nothing. Okay, so you can see that this template has two parameters, t and another one which is not named. And here, the second parameter just doesn't do anything, but it accesses this member, okay? This member of t. So it creates like an instance of t here and accesses that member. And the idea is that if that member doesn't exist, this template will fail. And the compiler will just return you this one. Does it make sense so far?
Yeah.
Okay, but in the other way around, if this doesn't fail, the compiler will choose this one because there is another rule that tells the compiler to choose the more specialized template variation. So what this will do, it will basically just tell us if that t value has that member or not, which is very useful because you can do this thing here. And now we can actually go to the ECS stuff. Any questions related to templates?
I love ECS. Let's go.
Any other questions?
You still haven't answered my question about being able to specify what types templates can be.
Yeah, you can. It's actually something that C++ community realized that they can do by mistake. It's also similar to what I showed before. I won't go into detail. You can look into this video. It explains it very well. There is something called enable, and it also this guy also shows it. It's very nice. It's something called enable if, which is inside type traits. And actually GLM uses it. For example, if you use GLM radians, it won't work if you don't pass something that is a floating point. This thing looks like this. Enable if t, and you can pass it, I don't know, like it has to be a true or false variable. This can be something like is floating point, float. Enable if, and what else does it want? Value. Okay. This thing, the idea with this is that I can pass it inside a template here. I haven't done this in a long time, so I probably do it wrong. I can put this thing, let's put it as a return type, because that's the easiest way of doing it. Now wait, well, I don't remember how to do this exactly, but so sorry about this, but the idea is that this thing won't give something that compiles unless this t thing is a floating point. Does that make sense? So like enable if will return void if this is false, not allowing this thing to compile, but it will return something that is not, I don't remember how is it, yeah, don't remember exactly how it works, but it will return something that will make the templates fail. But I haven't done that in a long time, so we watch these videos here for more proper explanations. Anyway, any other questions before we go to ECS stuff? I suppose you can still hear me, right?
Yes.
Okay. Let's do ECS then. So we'll start with a very simple entity, dropped item. So for each entity, I have 3 entities because I need to update them separately in the server side and the client side. And also I need to send data between them. So the first entity is like the common thing that will be both on the server and on the client. And in this case, it's like the block type and the count, you know. And it's also a physical entity. So to specify components, I just inherit this type. Let's search it. Physical entity, which has, you know, a position and yeah, stuff like that. Okay, let's go back. Now, this thing is also the thing that will be sent between the client and the server. So the server, to update the dropped item, will send this data here. And this is also how I'm automating the networking stuff. If I search for it, yeah, this is how packets look for a dropped entity item. And if you look at other entities, they all look the same. Like for the zombie, they look the same. For the pig, they look the same, but they just use their own, you know, own entity type. The only drawback with this approach is that I kind of have to repeat some code, but it's not that bad, you know. Okay, so getting back to this, then I create 2 new entities, which one is for the client, and I inherit this special thing, and one is for the server. Now, here, whenever I'm creating a client entity and the server entity, I'm also specifying as a template the base class that I'm using, like the base entity type, because here I'm also declaring, where is it, client entity, yeah, I'm also declaring it here. Why did I do that? Because it was easier to access it like this. Like I can just, you know, access it like this. If it was, if I were to declare it here, I couldn't have accessed it so easily from this thing. Does it make sense?
I just noticed that. Is that a struct inheriting from a class or from another struct?
No, they're all structs.
Man, why does C not have that?
The class and season structs are the same thing in C++, by the way. Anyway, and also you can see that I'm inheriting from myself here, which is something called the CRTP, if you want to search that online. It stands for Curiously Recurring Template Pattern. And it's also something that they discovered by mistake. What's the idea? The idea is that, where is it? The idea is that I can use the base class and cast myself into the base class in order to access things from the base class. So like in this way, where is it? This inherited class can access members from the upper class, from the parent class, which is kind of useful in this situation. Did that make sense?
Yeah.
Okay. So every entity here will have an update function. The update from the first function will just be common. So like for example, I need to simulate physics, both on client and server. But then I also have some update functions separate from the client and for the server. So the client's update function, for example, won't do anything special right now because I haven't done anything. But if we look, for example, at something like a pig, let's take a look at pigs. Okay, so the same deal here. The common update function will just do collisions. So this will be done both in the client and the server. And if you look at the pig client, this will call the, the common entity. But if we look at the pig server, this will also do the collisions, but it will also do the AI stuff, which is also another component, this thing here. And also, I also have this function, set entity matrix, that every client entity has, that will be used to animate the model. I won't go into detail, but basically this specifies how to put the, let's say, limbs and parts of the body, how to rotate them around in order to animate the model. Okay, did the things make sense so far? Maybe you can ask if you...
Yeah, it makes sense. Yeah.
Okay. Bro.
What the hell is that? Okay, sorry.
Okay, so. Bro, no, don't stop it.
At least it's not porn.
Yeah, fair enough. Going back
That has
to...
happened before, question mark?
No, fortunately. Okay, going back to the rendering. This is how I update my entities, and this is where the compile time stuff here. Where is the function? Entities, okay. So render all the entities. So every entity will be in its own separate container. So yeah, so we can see that every entity will be in a separate container, which is a little bit annoying. But what I do is that I call the exact same function for every entity. Like for the humans, where is it? For the players, for the, for the zombies, for the pigs, for everything, I just call the same function. That is a lambda. And it uses templates because the container, if we go inside here, I'm using this get body rotation matrix, which if we go back into the entity component system stuff, it's something that every client entity has. Let's take a look at client entity. Get position, get rubber band position, and I don't even remember what they use there. Where is it? Get body rotation, okay. If we go back to entity, yeah, this thing here. This will just return me the rotation matrix using this function. And if we go here, oh, this uses this thing that I showed earlier. So if my entity that I'm updating over has a body orientation, it will use its body orientation. If not, it will just return a default rotation, which is, just facing a straight, front. And things continue like this for the whole of the update. Let's take a look at the server, for example. Common, how is it called? Generic. I think it's called generic update. This is for the client. In this case, it's not very interesting. So I just call again. This is the client side stuff. For every entity that I have, players, dropped items, zombies, pigs, and cats and whatever things I will add, I just call the same thing, the same code, which calls this function that each client has. And again, it will just, if it has a body orientation, it will do some stuff regarding it. If it has some, look, this component, for example, it's used to animate legs. And if it does have this component, it will also update it. If not, it won't update it, and so on. Let's take a look at the generic update for the server. If I can find it, tick.cpp. And here it is. So this function, generic loop over entities, is called for each entity type. So dropped item, zombies, and pigs. So what it does, it will just iterate through the container, which again is a templated stuff. So I just press it, hey, this is the container that I want you to iterate over. Then I just call this function, generic update call, which again is also templated very heavily. It will just take any entity type that I have, and it will just call the, its update function that I showed earlier. It will also compute this thing here, only if it has it. This has to do with some networking stuff, and also here. This has to do with like the time delay from when the player sent the item to the server. For example, the player can spawn a dropped item, and it will have some delay until it will, until it will get to the server. And here I'm calculating that delay. Other entities won't have this component, like they won't have the timer delay. So this is a const expire if, so it just will just disappear. And then I just call the update function, which every entity has. And this is templated, so this doesn't care what entity I give it. It will just call the update function using the, the parameters that I gave. By the way, the parameters are stuff like, the current delta time, chunk getter, which allows us to get chunks. So like to do collision. And the chunk cache is like another thing that allows us also to get chunks, but it's like a little bit more powerful. And this is just in the server. The clients just get access to this. This also could potentially, this also stores entities and other stuff. And I also pass the random number generator because it made sense to do this. Okay, so let's go back. And then I do, I just send the networking update stuff, which I'll have to refactor later, but this is also templated. So I just, specify the packet type that I want it to be, which can be like either, as I showed earlier, they all look the same. They are all called entities here, so it doesn't matter if they are pigs, zombies, or dropped items. Whenever I'll call this thing here, I'll just use the current packet, whatever it is, and it will just send to the entity, which can be either a pig or a human. It doesn't matter, it will just send it. And the other two things are always the same, like the timer and the entity ID. Okay, and yeah, this is about it. I'll also maybe talk a little bit about how I made the server be multi-threaded. But until then, any other questions about the ECS? Maybe I can also show how I actually write some behavior for something. But anyway, any other questions regarding this thing? Was it clear how I explained?
Yeah, it was great explanation. Thank you.
Okay. So this, for example, is the animal behavior stuff, which also is, of course, templated. It don't even remember what E is, to be honest. But let's see what was E. Okay, so E is the base entity in order for me to access its position. And in the settings, I can actually change how the animal behaves. Like for now, I just changed the mean and max speed. But in the future, I could, just add stuff like personalities to animals. And then I using the things that I showed earlier, the chunk getter, the random number generator, delta time, and server chunk storer, and also these methods like get the position of the entity to just update my thing normally. So like this doesn't even look like networking stuff because everything is done for me already. So like I can just I have a wait timer here which decreases to determine where the pig will go. Like every time this reaches 0, the pig will just choose another random direction to go into. Like look, it will choose the direction, the speed, and I can just If it is moving, I can just apply that direction. And if it sees a block in front of it, I can use the chunk getter to get the chunk where I am and get blocks there. If in front of me is a hole, for example, I can just tell the pig to stop, and you know, so on. And in the end, the code that I showed earlier will just handle the networking stuff for me, so I don't need to deal about that. Don't need to worry. And if you take a look inside this, so this function is basically the game tick of the Minecraft world, right? But how it functions, so it just well, for now it just does the entity updates. You can see that it updates the, you know, the zombies, the pigs, the dropped items, and all of that stuff. And it will also update blocks in the future, like it will make grass grow and so on. But the idea is that this thing will use what I showed a little bit earlier. It will take some components. Remember when I showed taking components in a function like this as parameters? Well, the idea is that I'm calling this do game tick for each chunk region in the game. If I actually let me show you this thing here. Let's I want to draw a little. So if I have let's say a player here, okay, and let's make another player here. Let's make another player here and another player here. They all have their chunks loaded, right? This has these chunks, this has these chunks, and sorry for drawing that bad, this has these chunks. Well, I just have all of these chunks loaded inside this struct here. Fuck, sorry. Okay, 1 second. Okay, but then I just what I do is that I split them into different containers of the same type. I just determine like if they don't touch at all or not. So for example, if there would be another player here that would also load these chunks, they would all be like together. They will go in the same bucket because they touch each other. But chunks that are far apart, like these 3 regions here, they go into separate different buckets, okay? So if we go here, this is like all my chunks, okay? So what I do is I do a BFS here in order to determine what regions are separate, and then I just create a different chunk, chunk store for each region like this. And then what I do is that I do the game tick function that I showed earlier only once for each region here, but in a different thread because they don't because they don't touch each other. So if they don't touch each other, they can't possibly introduce race conditions. So for example, for this player here, it will get these chunks, and also the entities are stored inside chunks. So the game tick update will know about all the chunks that it needs, all the entities, and also the players. And it can just, simulate that locally inside it. And another chunk region can also do that independently in another thread. Because, it will also have its own chunks, its own entities, its own players. It's also faster because it doesn't need to know about the entities here. It can just iterate through these entities. Did this make sense?
Yeah, I just wanted to ask, what do you mean by BFS?
BFS, breadth first search.
Okay.
Yeah, basically just a coloring algorithm. Like I just take the first chunk in the array, I do a BFS. So like I just look at all the chunks here, I mark them, I put them in a bucket. Then I take the next chunk, which was not already in a bucket like this one. I also look at all of the name-buried chunks until I run out of chunks. Then I take the next remaining chunk, until I color them, until I, well, put all of them in a different bucket or color the regions. Yeah, exactly.